Hello, boys and girls. Welcome to Mrs. Bandu's Math Movies. This is Course 3, Lesson 4-4, Similar Figures and Proportions. What we want to do here is identify similar figures and to use proportions to find missing measurements in similar figures. Okay, there's going to be a lot of detail in this, so there may be times when you're going to want to pause and catch up and process here. I try to be very careful not to make mistakes. Certainly if you find them, please point them out to us in class so we can all make corrections if we need to. Sometimes your eyes are better than mine at catching my mistakes. So, okay. Vocabulary and key concepts. Similar polygons. If two polygons are similar polygons, then corresponding angles are congruent. And remember, congruent is the geometry equivalent of equal, all right? And lengths of corresponding sides are proportional. So that's where our proportions are coming in. So we're going to be using geometry and measurement as well. Okay, now the definition of similar figures is as follows. Similar figures have the same shape, but not necessarily the same size. Okay, so for example, all squares are similar to each other because they all have 4 congruent sides and 4 right angles, but they don't all necessarily have to be the same size. Okay, congruent angles have equal measures. Okay, as in the case of squares, all of them, each angle would be 90 degrees. Okay. All right, and here we go. Identifying similar polygons. Is rectangle ABCD similar to rectangle RSTU? And explain. So we have right here, study your diagram, get your stuff lined up here. Okay, so first of all, we'll check whether the corresponding angles are congruent. If the angles are congruent or not congruent, there's no point in moving on. Okay, so angle A is congruent to angle R. Angle B is congruent to angle S. Angle C is congruent to angle T. And angle D is congruent to angle U. All right angles are 90 degrees. So that one's pretty easy to see. We should know that they are congruent. Okay, next, check whether corresponding sides are in proportion. So AB corresponds to RS, and DA corresponds to UR. Okay, set up these ratios like this so then you can know how to get your sides in and what to substitute. So AB has a length of 6 where RS has a length of 48. DA has a length of 3. UR has a length of 24. So substitute in like that. Okay, I'm going to do my cross product. So 6 times 24. We want to determine, does that equal 48 times 3? Again, notice I'm keeping my top numbers on the same side as they began, or my numerators. So 6 times 24 is 144. 48 times 3 is also 144. The corresponding sides are in proportion, so rectangle ABCD is similar to rectangle RSTU. Also a nice little trick, if in fact they are similar or A is going to match R, that's kind of a little shortcut way of matching up what should match angle-wise. All right. Line them up and sort of connect them. Sometimes people find that helpful. Okay, in number 1, you have a quick check. Go ahead and have that completed by the time you get to class. Either do that now or do it at the end, whichever you choose. And let's go here. Given that rectangle EFGH is similar to rectangle WXYZ, find T. So it's telling us that these, in fact, are similar. And again, the little trick I just showed you there might come in handy here because we see that these figures are rotated a little bit. So WX should match EF. So sometimes you might want to draw lines to them or somehow keep track of that, but you do have to match that up. So EF corresponds to WX, and EH corresponds to WZ. So WZ okay, so we're going to substitute what we know. So that gives me EF is 9, WX is 12. EH is 3, okay, and WZ is our unknown of T. Right as cross products, so that's going to be 9 times T equals 12 times 3, so 9T is equal to 36. Divide each side by 9, so T equals 4 when we simplify. It doesn't give us a label to go with that, so we just leave it as simply 4. We don't know if that's in inches or whatever, and it doesn't matter at this point in time. Okay, number 3 is a slightly different take on similar shapes. They're overlapping. In other words, this looks like one giant triangle with a line drawn across here, when in fact it's meant to represent two separate triangles. They just happen to be overlapping. So sometimes it's very helpful to actually in fact separate the triangles, because this way you can just get a better visual of what you're trying to match up. Okay, so triangle RST is similar to, remember this little symbol means similar to, triangle PSU. So I'm going to write RST up here, and notice that S logically corresponds because they share point S. Both of them share that vertex. Okay, so SR corresponds to SP. RT corresponds to PU. Now the length of SR is 12. The length of SP is 21, or 12 plus 9. You need to be very careful about that because 9 is only the length in here between R and P. SP is the whole thing from here to here, so you have to add those two together. And let's see, RT is 14, okay? And we have the variable D given for PU. So we'll go ahead and throw in the D. Do my cross product, so 12D equals 21 times 14. So 12D equals 294. Again, I'm going to double check my math on that one. 21 times 14 equals 294. Okay, so then we're going to take each side and divide by 12. So we take 294 divided by 12 is 24.5. 12D divided by 12 is simply D. So the length of PU is 24.5 units, whatever it is. Okay, all right then. You have a couple of more quick checks. You have 3 altogether. Please have these completed before we meet in class next. Also, please, as always, write down what you're doing. Write down any questions you come up with as you're working, and we can have something to discuss and go from there. I look forward to seeing you in class. Bye now.